where some of the consultant opinions sit. But now we're going to start getting into the techie stuff. Go for it.
All right, excellent. Thank you. Could we dim the front lights for the, I have a couple of videos that will be going on. All right. First of all, thank you, Cyber Senate and Jameson and Company for having me on this side of the pond. So our company is based in Texas, and I'm going to go very quickly through a lot of these slides. And don't worry about having to take pictures of anything, because I'm going to give you the full PDF of the whole deck. So I'm going to skip through all this, but basically my background is I'm an electrical engineer that got converted into cybersecurity in 2001 and helped author the original ISA 99 standard over 20 years ago, and I've been in OT cybersecurity the whole time. You can tell I like it a lot, I'm still here. So I'm going to skip through a lot of this. You know, you guys have seen all these news about attacks affecting transport systems, and it's all in the PDFs for you because I want to save time for the juicy stuff, all right? This was a pen test project that we worked on. The company had hired us to try to attack their system from the internet with black box, basically no diagrams, no IP addresses, nothing but their name. And we were able to tunnel all the way down into their control system, find, this was a Modicon PLC, it was kind of an RTU with Modbus TCP interface. We were able to affect the coil that was the emergency shutdown coil, and we were able to send a signal to that from the internet. And then we found that they had over 1,000 of these, and we could have wrote a script to just execute that coil over port 502, and then within probably less than 3 or 4 minutes, we would have had 1,000 RTUs that would have emergency stop signal sent to them. We also were told to try to hack them from the field sites. So, you know, we rolled in with contractor outfits on, found the boxes that was doing the communications. A lot of these field systems, as you know, are using cellular as the last mile of communications. So once we opened up the box, we found the Ethernet cable that was going into RTU, connected up to our laptop, and of course there was no security, everything was flat open. We were able to go from that field site all the way backwards to their control center, and we had full control of everything. Actually, we could go all the way out to the internet too. You can see this is Apple's webpage behind us. And this is just a proof that we were on the internet from the field side. This is just a quick rundown of the Colonial Pipeline ransomware attack. That's everything you need to know. It is right here about that. But the timeline is interesting in that from the initial intrusion all the way down to the congressional hearing was less than a month, and these types of attacks do move pretty quickly, as you've probably heard either through your own interactions with ransomware or through your friends who've had issues with those. And what we're seeing in terms of attack vectors still being used, remote access is still one of the biggest accesses. And of course, that was a really interesting presentation we saw earlier today about how remote access systems have progressed a lot these days. So let's look at hacker and penetration testing methodology. So if you don't think like a bad guy, well, let's at least try to put ourselves in their shoes for a little bit. They're going to spend a lot of time doing reconnaissance. If it's a physical target, that means driving by the place, looking at what kind of clothes they wear, what type of badges they wear. If it's a digital asset, we're going to do the same thing with doing port scanning and looking at what the attack surface looks like, figuring out what type of exploit we want to weaponize for the vulnerabilities that are there, and then delivering the exploit, and then making sure we can get back in afterwards, because if it's a memory-based attack, and someone reboots the machine, then we lost our shell, so then we're going to want to have persistence, usually through remote access tools, and then achieve our objectives, and then clean up so that there's no proof that we were there. So if we look at a typical, this is the ISA 99 IEC 6443 Purdue model, where you have at the top internet-facing systems, and moving your way all the way down to the bottom where you have process control and instrumentation. A lot of the OT sites that we work on have both a core HQ and then remote sites, and those remote sites have IT users, business users, even sometimes public kiosks that would be connected back to HQ through typically IT or WAN topology. But then at those sites, there's also industrial operations. And so if you convert that to your industry, maybe on a train, you've got control systems on the train, you have IT systems or internet systems all on the same train. So you have to have some type of segmentation at the site as well. And so what we wanted to do is break down some of the typical vulnerabilities that we see by each of these layers, right? I'm going to skip over the internet and enterprise layers. I'll focus more on the control system side. But if you get access to the system here, which is typically done through phishing, is still a big attack vector. Remote access systems was the preferred target attack vector in the last 2 years. Then you can basically play at will on the enterprise layer and find those connection points downward in the architecture. A lot of standards that we're seeing today is calling for multi-factor authentication through an intermediary device. I know NERC SIP has that built into version 6. TSA is pushing that as well. But MFA is only as good as you implement it, right? We are seeing social engineering attacks where they're calling into the user, asking them to read off this because they're the IT help desk and needs to fix it, so they get the other side of the token. We're also seeing eSIM and SIM porting attacks. I don't know if you've ever experienced that here in the UK, but in the United States, you can call AT&T or Canada Rogers, your carrier, and then if you give them enough information, you can get them to port the number. And so hackers are porting the phone number over to another device, and they actually have the second part of the MFA. So these are some things that we want to focus on when you're doing training to your own employees, because that's all, social engineering is still a big part of it. Now, if you're targeting an operational technology site, you're probably aware that the data historians, data transfer systems, remote access systems, those are all going to be really juicy targets for you because they have to have connections upward, and then they also have to have connections downward. And this is the next level in the system that I'm going to talk about. They have the same vulnerabilities as we talked about before, the enterprise systems. What we're typically looking for are like the Pi historian port 5450, SQL Server port 1433. We're looking for systems like unpatched Apache and IIS web servers. The systems in these DMZ layers are it's kind of like a no man's land because the IT side doesn't really manage it, but then the OT side doesn't really manage it. So those things in the middle, they kind of get left stale for a long time. And as we move down in the architecture, you'll see that we're starting to lose the effectiveness of good cyber hygiene and endpoint security because we're moving further and further away from the core of the IT cybersecurity solutions. And we're getting more and more detached from IT and the internet, which is probably a good thing. Although those systems, as we move further down, is probably not going to be patched, probably not going to have endpoint security on it. So what can we do if we have no knowledge of a system and we think we might be either one layer away from the operator workstation, or maybe we're on the same network as the operator workstation. We have no usernames or passwords, we have no credentials. How do we get access to that operator workstation and control that SCADA system as if I was sitting in front of it? So here's a quick little demo. We're going to start with reconnaissance. So this is just an Nmap sweep, and instead of sweeping for all systems, all ports, what we want to do first is be very judicious in our scans and surgical. So we're going to do basically a quick scan to see what hosts are up on the network, And then we find these, some of these hosts are named by the vendors, like Delta V, is an Emerson box, so that's probably a giveaway there. We're not always that lucky, but if you do a very quick port scan, you'll see that that system does have some interesting ports open. We're going to scroll up and see. So the host name is Delta V, and it has the Delta V UDP ports, the 18,000 ports used by that protocol. You could substitute, Profinet ports for Siemens, or Modbus ports for, port 502 for Modbus TCP. Now we know that that machine is being used by the SCADA system. We don't know if it's a front-end server, or if it's an OPC server, or if it's an engineering workstation, or if it's a console, but we know it probably has something to do with the control system. So then we're going to take that IP address, put it back into the scanner, and then scan for all the open ports in that machine. And in this case, we found that there was NetBIOS, the typical Microsoft ports, and then we're going to see an FTP port. And some of these SCADA HMI vendors, they have a lot of open ports for various tools that have to run for maintaining the system, which means the more ports open, the more services open, means more attack vectors for the pen tester. So now that we know that we have its IP address and we have a target port, we can then load up Metasploit. This is the web interface version of Metasploit, which is a long time has been deprecated, but it makes for a good demo. So we're just going to basically plug and chug the IP address, the port, pick the payload we want to send to the machine, and in this case, we're going to do an injection for an FTP service that we know is vulnerable. And if we're lucky, the demo gods like us, then we'll get a shell. And here's our VNC service that we injected. So basically we injected a little small amount of VNC onto the machine and then was able to remote access to it. So now we're able to do anything that we wanted to as if we were sitting in front of the machine. So we have full system privileges. Now, if you're using a different toolkit for access, sometimes the attacker does not have full system access. He has the access of the user. So then they'll have to do things like take the SAN file offline, crack it, then they can get admin privileges. That's how they do privilege escalation. So what if we're on this side and we want to get down to the controllers? We don't really have to move all of the all the weapons that we need to use onto a box anymore. We can just load it into memory and pivot. So this is called a pivot attack. And again, we're going to use Metasploit again. And in this case, we're going to find a machine that's vulnerable to an exploit. I think in this case, we're going to use that same FTP service vulnerability. But instead of, our goal is not to get onto that box, but our goal is to get a shell on that box and then add a route to that box, so then we can go from that box onward down into the next layer of the architecture and keep all the tools that we have on our machine. So as we're basically building ourselves a tunnel down through the architecture to the PLCs and RTUs, and then that way we can use our own tools to then fire and turn on and off coils, turn on and off memory mapped I/O. So here's where we get our first shell onto the intermediary box, and what you'll see, the next thing we want to do is add a route. So basically, this is another reason why you should not have dual home servers. I know that everybody preaches about that, but unfortunately, that's how a lot of systems were designed. And so you got stuck with these machines that had more than one NIC card on it. But if an attacker comes in one NIC card, you can go out the other NIC card. And in this case, we got onto the NIC card and added our own route. So basically adding another subnet onto that machine so that we can then route through that machine further down. So the machine that we're on, we did a scan of other machines past it. We found one that responded back to port 502. Fortunately, we wrote our own little Modbus Metasploit tool that allows us to then enumerate the Modbus services allowed, so then we could then write to coils and read coils and read and write to memory addresses. And we're doing all of this remotely just by pivoting through just a target machine. A machine could be anything. It's just a machine that lets us get onto it and target and pivot off of it. And then this was the little Metasploit exploit that we wrote that basically allows us to enumerate the protocol functions and be able to basically interact with that PLC or RTU remotely. So now if we're down here at level 3, level 2, we're sitting at the supervisor HMI area. What are the other vulnerabilities that we're seeing at this layer? So a lot of these machines have shared resources. As if you guys are practitioners in the SCADA space, you know that a lot of the vendors want you to share the C drive out. We're finding that a lot of the usernames and passwords are reused across multiple machines because of shift workers. They're not using individual accounts. We also find that all the workstations and servers at this level have access to all the other systems at that level, and they have access to all the machines above them and all the machines below them, all IP addresses, all TCP ports, all UDP ports. Now, if you're using proper segmentation, you could make it a lot more effective by containing only the systems that need to read and write to the PLCs, and then not allow everything to write to each other. We've collected also over 30,000 vulnerabilities, so we went to over 400 OT vulnerability assessments in plants around the world since 2002, was when we did our first assessment. And we started doing a bunch of research and looking at the age of the patches on the machines, and then the date when we were there doing the assessment. And we found that if you did an average mean of them all, the average age of the patches on a SCADA machine is about a year. So if you're patching your real-time systems better than a year, then you're doing better than average. Okay. We had some outliners showing that it was over 7 years on some of them, but we were patching systems every week, every 2 weeks on the IT side. I think the best you can hope for is maybe monthly patching or quarterly patching on the real-time side. But it's harder because those systems are further removed from your core, so it's harder to just push patches down there. Also, endpoint security continues to be a problem. And we're also found that over 65% of these systems at the supervisor layer also had remote access tools on them, like TeamViewer, and these are all left by the guys that are managing the systems or vendors for remote support. And so when people say that their real-time control systems are isolated, air-gapped, not connected to anything, based on our research and work in this field for the past 20 years, I can tell you that you probably have more systems connected to more things than you realize, or you have people down there connecting it to vendors and other things and you're not aware of it because they're not reporting back up to the same IT security group. So lastly, let's get down to the process control side. What can we do here? Well, this area is the least monitored of all. And this environment, most things can talk to other things, and you don't have a lot of monitoring going on, so you pretty much do whatever you like. You can view, modify, delete internal memory registers. You can overwrite internal logic. There's very few controllers out there that have user-based passwords. Like they don't support Kerberos. They're not going to support Active Directory. So basically, if you're on that network and you have the right workbench tool, you can overwrite the ladder logic or read and write to any register you want. You can also intercept, inject, manipulate data. Most embedded ICS devices do not offer SNMP. So it's difficult to monitor their health if they're up, down, or if someone's rebooted it, or if someone's tampered with it. There's not really an elegant way to monitor the health and performance of embedded devices, although the industry is starting to pick up and add more security services down at this layer. They just really don't have the security capabilities that an IT network connected device would. They don't also support syslog. Also, you can't turn on or off different services. So if you get a box from the vendor and it's supposed to control something, you can't go into it and say, I want to turn off its web interface, I want to turn off Telnet, I want to turn off FTP, I don't need this SSH shell in it. A lot of these boxes come as they are, you can't tamper with it or change it. So here's another video. I'm going to show you what we did with Momentum PLC. This is from Schneider. Again, all these videos, they're not meant to target any particular vendor. You know, I'm showing you, a little bit of Emerson, a little bit of Schneider, all these different things. I didn't show any Siemens, so don't shoot me. But this is just indicative of the class of devices. And you know, the vendors are waking up and adding more security services in them, but we're still finding that you know, you can do things like this, like, you know, the web browser interfaces PLC, you know, allows you to go into it and overwrite. And so we were able to, instead of showing that it was running, we showed that it was stopped, and it really wasn't stopped. And then lastly, we just said, okay, let's just take the whole interface off and just say that we were here. And so you'll see another message come up when we get refresh. Yeah, so I live in your PLC, hacking your SCADA, all your PLC are belong to us. So, and that's because, you know, these systems also don't have memory protection. There's no way to also even do rogue device detection. So if you can compare, you know, IT devices that you're buying today, and you compare it to OT devices, right? You would think, well, shouldn't they support all types of authentication like LDAP, AD, you know, all types of PAM solutions? I mean, there's enough processor power on this embedded device to support that, but not really. What about encryption? It should have multiple options for encryption, like TLS or certificate-based or AES 256. There's typically no options for encryption down there either. What about device monitoring? Maybe if you're lucky, you'll get SMP version 1 or 2. What about turning on and off different services? You don't really have access to that. What about forensics? syslog? What about, no, probably not. What about code locking or memory protection? Probably not. So what we're trying to do is promote to the real-time control system vendors that if you just look at the standards that's already available on the IT side and you give those options to the asset owner, then they can turn on those options and start to manage their OT devices in a more elegant way. And that would give us at least a fighting chance to keep the bad guys out of our OT networks. But we're trying to do that with like 1980s technology, which is difficult, you know. So now if you were to jump into the wireless side, there's a whole other stuff that you gotta worry about because we're not talking about wireless like, you know, Wi-Fi. You know, a lot of these industrial systems are using wireless I/O, wireless HART, ISA 100, and these are different than what you would find in your office-grade commercial Wi-Fi. You can even use basic, inexpensive two-way radios. I'm going to show you a couple of things you can buy on Amazon that allow you to connect it to your computer and then start to discover devices that are communicating in those frequency ranges. And then once you collect enough traffic, then you can start to inject your own traffic back in, and then the world is your oyster, right? So this is one that's, I think, like 20 bucks. And you can connect that to your computer and use software-defined applications to then make it do things outside of its range that it was intended for. There's another one, $25. So, I mean, this is not outside the range of the capabilities that's out there. So how do we, I don't know where to probably, how do we fix this, all right? I don't want to just tell you all the bad stuff out there. I just wanted to open your minds and let you realize how easy it is that for these things to happen. You don't have to be a state-sponsored threat actor to do this to your control system. Just a little bit of research and probably a little bit of scratch money. You can get together some tools to do it. So this is kind of like a mirror on the wall for you to look at and see kind of where am I at my process of building out my OT cybersecurity program. We started modeling our clients about 10 years ago with this process. So if you're conducting assessments, defining the standards, formalizing a common architecture, those are the things you should be doing under the first phase of work and rolling up your sleeves and building your program, because everything else falls from that. Once you have your set of controls and standards defined and a common architecture, you know your weaknesses, then you can build a training program to train your users. You can then go request funding from your management for projects that you want to fund that are based on actual gaps you discovered from your assessments. And then you can start doing the real work and deploying solutions. Many of the solutions that you probably saw out there in the vendor hall are solutions that probably are a good fit for you, but it's difficult to go to your boss and say, hey, I saw this really cool thing and it's gonna help us a lot. Well, if you do an assessment that shows the gaps, the technical gaps and the controls gaps, and you can map those gaps to a need, then that is traceability. That provides management with the reason why you need to have the money to invest in cybersecurity. And then you're gonna roll out all your cybersecurity programs, and then hopefully when the system's dialed in, you're gonna do routine annual rechecks of the system to make sure that your program is being effective. So this is kind of like a high-level model of what we try to take all of our customers through. First, define your target state, which is based on the control protocol that you pick. And then determine your current state, and then determine your risk and drive your gaps. So we just did this for FIFA World Cup, right? The target state for Doha, Qatar was the QP standard, the NIST CSF standard, and then FIFA had their controls as well. So we built a controls matrix of all the required controls. That was the target state. We went out to several sites that was underneath this FIFA World Cup requirement to make sure that the OT systems in Doha, Qatar was going to support transportation of people and all of the requirements for the games. We determined some gaps between the current state and the target state. We built a roadmap and were able to drive it through in a short time. Sometimes this strategic roadmap could go on for years though, if you're building a multi-year program. So to wrap it up, sorry, these glasses I'm wearing is HD glasses, records. So we were doing a physical pen test and I was carrying a bunch of pizzas into a place and just was recording the whole time how we were able to walk all the way through to the end. So just make sure that your physical security matches your cybersecurity. And this is basically just a run through of you basically take all your control platforms and have a current state defined, and then you do a target state definition, and then the difference is where your gaps are. We like to take the gaps and move them into high, medium, and low gaps, and then those high, medium, and low gaps, which could be technical gaps, it could be procedure policy gaps. These are the policy ones that failed. Those roll up into threat model. So basically what controls you're missing, if the attacker has access, and it kind of elevates that control as a higher risk control. So you have to also do threat modeling as part of your risk assessment. And then at the end, we built a roadmap. We created capital project investments over a period of time that allowed our customer to get to that target state. We did this process with all these companies that gave us the go-ahead to talk about at least the fact that we did this process with them. And I'm going to leave it at that, since we're...
Still got time. You've got a lot in there, you go back.
67 slides in 25 minutes.
Thanks, Jonathan. I think one of the key things there is that I come across quite a lot as well, is the setting your target state. Because a lot of companies I talk to, the immature companies when it comes to cyber, say, well, obviously I want to be compliant. You're like, okay, that's £20 million in 10 years. You sure you want that? You might not need it. Yeah. So what is it you're trying to achieve? What is secure enough? What is pragmatic? What's good enough?
That might be a hand with that too.
Yeah. And setting out the road to get there rather than just trying to be perfect doesn't quite work. Okay, thank you very much. So,